Hello everyone, welcome back to the channel. I hope you guys are doing amazing. So let's dive into today's daily challenge on Leetcode and try to solve it. So we are given this candy problem. There are n children standing in a line. Each children is assigned a rating value given by the integer array. You are giving candies to the children. Each children must have at least one candy, and the children with a higher rating gets more candy than their neighbors. But for equal rating there can be anything. We need to just minimize the number of candies. Okay. And you need to distribute the candies to the children. So first of all, before going to the solution, you must try this question on your own, because this is a very simple problem. A hard problem easier than this is not possible. So I will definitely tell you to first try it on your own, uh, and then go forward with the solution. And if you see the one of the example, 102, so what you can do is initialize all the candies by 111, and you can since this one is greater than this zero neighbor, so it must be having more than one, so it is having two, and this two is also having two, because it's just need to be more than this zero. Okay, so that's why you can allocate the first, second, and third child one, and two candies respectively, which makes a total of five candies. Okay, so after trying, let's try to see the approach. Yeah, so we will see a DP solution to this, and linear simple, we will try with simple linear DP. So how we understand that we need to do DP? Because you see that we are given ratings, right? Ratings may be like 1 0 2 as shown here, and you need to know that every child must get one candy. So if you initialize the DP by something like 1, and if you just try to check the neighbors, the 1 has the neighbors 0, so you can say that it must be more than 0. The 2 has the neighbor 0, you should have tell that this guy should have more than this neighbor. So this is how something you can calculate by initializing some DP array, where DP of I denotes number of candies which is achieved by ith child. Okay, so this is what DPI means. And specifically, if you try to think of an increasing array, like the rating is, let's say, 2, 3, 5, 6. So you see, if you initialize 1, 1, 1 to all, so you need to know the previous information of the child. That's why the main hint of using DP comes in place. So let's say this 2, you start with this 3, which is greater than this 2. So it definitely needs to be more than 2. Okay, so you initialize it to 2. Now this 5 is greater than this 3, so it needs to be more than 2. So that's previous number plus 1. Okay, and this 6 might be more than this 5. So this 4. So one thing you can it can simply come to your mind that why not go through the array from I equals to 1 to I equals to n minus 1, and do dpi equal to dpi minus 1 plus 1. So the candies which is got by the ith child, I minus 1 child, you just need to get one more candy, because then only it will be optimal. 1 is the minimum more which you can obtain. But if you try to think of some cases of where equal number of candies is also there between the neighbors, and the candies are reducing also, I have considered only increasing, right? So if you to try to think something like, this is the rating 1, this is 2, this is, let's say, 87, let's say this is 87 again. Okay, so without 87, let me take just 8. This is also 8, this is also, let's say, 8, this is again 2, and let's say this is not 2, let's say this is 3, and then again it is reducing to 2. So this is, assume the rating. So if you have initialized the DP array to 1, what you can do, you see that this 2 needs to be more than this 1, so the candies should be definitely 2. Now this 8 rated guy should getting more than this 2 rated guy, So definitely it should be more than the 2 rated guy. So now this doesn't mean anything, right? So this 8 should be greater than this 8. So at first pass, let's say I am checking only my left neighbor. Okay. So when I am checking my left neighbor, this is equal number of, right? So there is no criteria mentioned in the question for equal number. So and it is also told that we need the minimum number of candies. So definitely we will prefer it keeping one only. Okay. Then again this is 8. We don't need to do anything. But if you see, now this 3 has reduced. Now this 3 has reduced. So at first you might try to think that let's go to the previous element and increment 2. Okay, if you try to do this, then what the problem you will face is that then you will say that okay, my previous element is having 2. Now if you go to 2 and see till that it's 3 should be having greater. Okay, the 3 should be having greater. Now you will end up in incrementing 3 to 2, and the thing which will be left is like the 8th rated guy should be greater than the 3 rated guy. So it should be greater than 2, but now it has become equal. You see, if there is a decreasing array, something like this, like 4, if you assume something like 4 3 2 1 rated, and you are just doing like if this guy is greater than me, I just give him 2. Okay, then again you are going to this, you saying that my previous guy is greater than me, I am giving 2. Then again you are saying that my previous guy is greater, I am giving 2. So what you have done is you have ended up in giving 2 candies to all of these, which is not desirable because the fourth one should get the maximum number of candies. So in linear pass, you see it is not possible if you just try to see the previous candies, but definitely for increasing case it is possible, right? So what you can do, since you get the intuition that for increasing case it is possible, and also a decreasing array is definitely increasing from the back. So this hint you get that. So what you do is that you leave as it is. If you see something is decreasing, you leave as it is, and when you and then again you do one more iteration from right to left. From right to left, as you do one iteration starting from the second highest index, you do the same thing which you have done in front. If 3 is greater than 2, just increment it by 2. Now if 8 is greater than 2, just increment it by 3. Increment it by the number which is greater than 2. So from backward iteration, if you are doing, what you will need to do is that dp I plus 1 should be greater than I, but you need to check, right? Always you do not need to do this. Suppose if something is like 1 2 3, and then again the rating goes down to 1. Okay, so if this is the case, something, so let's say in the initial rating you will initialize it by 1 2 3 only, and 1 only. So okay, so if you don't understand, I am just giving another example. This is a very bad example. Let's say 2 6 8 and let's say 3. Okay, so first of all you have all the candies as 1. If you go to 6, you will say that if you need more than 2. If you go to 8, you will say that you need more than 6. You don't do anything here. Now while iterating backward, if you say that I have more candies than this and I need to increment something more than this, like this is, you need to increment more than 1, so you will be in trouble because you will again end up in making this 3 to 2. So what you need to do is that you will do this only when the number of the rating number is uh, actually higher, but the candies count is actually lower or not or equal. So here the candies count is already greater for the greater rating, so we do not need to anything. Okay, if the candies count is not greater than the greater rating, for the greater rating, then only you need to do this second iteration. Okay, so that is all you need to do for this problem. Let's try to code it out. If you don't understand any portion of the code, you can definitely ask me in the comments. So this is the n. At first I told you I will initialize the dp array, where dp I denotes the candies received by the ith child, and I will go from 1 all the way till n and do check if ratings of I is greater than ratings of I minus 1. What I will do is dpi is equal to dpi minus 1 plus 1. You easily understood this. And I told that I will again for the decreasing arrays, which is increasing from the front back. What I will do is I will just start from this n minus 2. Okay, I will start from this n minus 2. I will go till 0. I will do j minus minus. I am doing a backward iteration. And I will see here that if ratings of I, the ratings of I is, if you see the ratings of I is greater than ratings of I plus 1, and and you also need to see that candies, current number of candies of I is less than equal to candies of I. So as I told you, as I just now told you, that you also need to check whether number of, in this case, as you are iterating from backwards, the number of candies is already greater for 8, so you do not need to do anything. Okay, so if ratings of I is greater than ratings of I plus 1 and candies of I is less than equal to candies of I plus 1, then only what you need to do. So what I am doing this candies, because this is the DP array, right? I have initialized the DP. Currently, the number of candies initialized by the DP is less. Then only what you can do is you can do DPI equal to DPI plus 1 plus 1. Okay. Now you need to do is return answer. Answer is nothing but the sum of all elements of DP, because that is the total number of chocolates, right? So you take x DP and add the x to the answer. You just count the sum of all elements of the DP, and that would be all for the solution. Let's try to run it. Okay. What I'm using, use of undeclared, and okay. I'm using the iterator variable as j here. So let me turn this j to I. Definitely that's not the thing you would want to do. So yeah, we do have the acceptor. Let's try to submit it. Yeah, we have the solution. The runtime complexity is also quite good, and that was all for the problem. All you need to understand is how to update the DP array and when to update the DP array for this problem. And this was quite a hard, easy kind of problem, I would say. And let's hope that your day is going to be really easy too. Thank you so much.